main cost to connect all points. You are given an array points representing integer coordinates of the same points on a 2D plane where points I values equals to um, xi and yi. The cost of connecting 2 points xi and xi, yi, and xj and yj is the Manhattan distance between them, which is the absolute value of xi minus xj plus yi, the absolute value of yi minus yj, where the absolute value denotes the absolute value of var. Absolute value of denotes the absolute value of var. We note return the minimum cost to make all points connected. All points are connected if there's exactly one simple path between any 2 points. So this is our return, what we need to return. Oops. So let's make why isn't this working? Oh, now it is finally. So let's make our let's name place points n equals to points, which will be the length of points. So now let's make an edge case. So let's get to example 1. It says so these are our points and our visual graph, and we have these. It says this is our the minimum total cost to connect all points, and here it explains it. It says 20, so it says we can connect the points as shown above to get the minimum cost of 20. So these it does show the point cost for each edge. The edge is the cost. So notice that there is a unique path between every pair of points. Points for this example, it just shows the graph. The points, and this is our output. Says that it's 18. So let's get into this. So we have our length of points, which is n. So edge case, if n is equals to 1, return 0. Now let's make a table and let's make an array to start. Visitation array. So let's call it visited equals to, let's make false times n. And then let's make total cost will be equals to 0, and our edges is called used equals to 0, and then we have our we have our min. We have, let's call it our min heap. Let's call it min heap. Yeah. Min heap equals to, let's put 0 and 0. Let's call it cost and point. So let's make our loop. We'll use primes algorithm Prim's algorithm. So while our edge is used is less than n, so the number, so while our edge is less than n, meaning as soon as it's equal to n, then it will no longer apply. So y is less than equals to, oops. Let's make let's name our current, oh no, let's name it cost and current, no, curve point equals to hip hop, and then min heap, we have to pop our min heap. Okay, that's it. So if visited, if current point, if our current point has been visited, meaning if through, it's going to be false starting out for now. Continue, so it won't apply now. If it isn't through, if visited, move to the next group. So let's check. So let's start adding up these. So our total cost will be cost plus cost, and then edges used will be plus 1. Visited will be 2. Let's put curve point in it. And then let's check. So we have this. So current point edges added. So let's move on to our loop. So for I in the range of n, let's call it next point, range of n, our distance for the next point's distance, which is the cost. Distance is equals to the absolute value of, the absolute value of curve point 0, curve point, it says it will cost x curve point, and then okay, minus next point 0. So this will be points. Let's make this all points. Okay, so now we can move on to, hold on, oops. So now we this, and now let's move on to the next one. Plus absolute value points curve point at the index of, hold on, let's move out 1 minus 1 points, our points list, and then the next one will be hold on 1. Oops, let's move out and make our next point, and that's it for this. So now let's move out of this and let's make our hip push and min heap. So into our min heap equals to put let's call it distance, it's distance, and then distance, and then our current point will be next point, and that's it, I think. Let's see if it works. Hold on, now we have to move out of this loop and return total cost. Main heap is not defined. Oh yes. Equals to visit that, another syntax error name message. And it's been accepted. Boom. And so these two have been accepted. So that's basically it. So what this basically is going to do is start out with this, make sure that our edge is less than our current number of points, so, for the loop to keep going on, because as soon as the loop is equals to it, so for example here we have 1 2 3 4 5, so we have 5 points, and 1 2 3 4, so it has to be less than it. As soon as we add 1 to it here, 1 to it here, and it's equals to this, then it will no longer be valid, so we can just return it. Now the loop will end, and that's basically it. So we add up the cost each time, so the distance is basically the cost, so we add the cost, and then we take the next point and pop it out here, and then assign it these values. Check if it's been visited. If it hasn't been visited, let's move here. If it's been visited, let's move on to the next value. So if it's not visited, let's take the cost, which is going to be the distance here, and which has been added, named cost, and then added the cost to the cost, and then take the edges and add +1, and the current, check it, mark it as current. Alright, so visit that. And then let's make a loop for next. We call this for next point in the range of n. So that's going to go from check all the value from. It's going to check to n to the n number of values we have. So the distance will be the next point. So uh, so if we start from index 1 or well, hold on. So it will check well for next point in the range of n. So this will basically go through the loop, how much we have in it. So it's going to start off from 1 and then so on and so on and so on. And then we name this distance, which is our cost. The This is the formula that we use to solve it. Points, current point minus the next point. And then that's how we get this. This is quite simple. And the time and space complexity is time complexity. Space complexity. O of log n log k plot n. Let's put because we have to go over this. Hold on. Equals to for heap plus our loop log of n. So heap move take using our heap function and then iterating for I in the range of n. That's log of n. So log of n that's equals to iteration and then that's equals to O of n log k. And our space complexity is O of n to the square of 2 because of this. I think this is log of 2 log n2. Let me check to see. Let me submit all to see if it works. All cases pass, and let's analyze complexity. And it is log of n, yeah. Log of n. Log of nk or n. And that's it for this problem. And